Hello, my name is Julian Vasquez, and I'm going to talk to you about hash collisions, also known as birthday attacks. But first, what is hashing and what does it do? A hashing algorithm is a mathematical function that converts an input into a fixed size string of bytes. This output is typically a sequence of characters or digits known as hash value or hash code. There are many formulas to a hash message, but a cryptographic hash function needs to have some qualities to be considered useful. Each hash value or output needs to be deterministic. For a given input, a hashing algorithm always provides the same hash value. This property ensures consistency, reliability in hashing operations. Fixed output size. Hashing algorithms generate hash values of a fixed size regardless of input size. Common hash sizes include 128-bit, 256-bit, and 512-bit hash values. The avalanche effect, a small change in the input, should result in a significantly different hash value. This property ensures that familiar or similar inputs produce distinct hash values, enhancing security and reducing the likelihood of collisions. Irreversibility. Hash functions are designed to be one-way, meaning that it is computationally infeasible to reverse the hash value to obtain the original input. This property provides security in cryptographic applications. In blockchain, hashes are used to represent the current state of a blockchain and to ensure its immutability. Cryptographic hash functions are generally considered secure. However, they are not immune to vulnerabilities. A downgrade attack. The attacker intercepts the initial negotiation between the client and server and manipulates the communication to ensure that the connection is established using a less secure version supported by both parties. Collision attack or birthday attack, which gets its name from the birthday paradox. It states that in a group of just 23 strangers, there is a probability of 50% that two people share the same birthday. It's not whether the second through the 23rd stranger share the same birthday as stranger 1, but rather, this is whether any two strangers share a birthday with one another. The high probability 50% with a low stranger count 23 is surprising, but the math works. The combination without replacement equation, n factorial over n minus r factorial times r factorial. If we plug in our numbers and replace 23 with n because the group is 23, and replace 2 with r because we are looking for 2 birthdays, working it out, it comes to 253 combinations with just 23 people. This is the basis for the collision attack. The attacker aims to find 2 distinct inputs that, when hashed using a hash function, result in the same hash value. This can be achieved by generating a large number of random inputs, hashing each one, and storing the hash value in a table. Due to the nature of hash functions, it is expected that some inputs will produce a collision as the number of inputs increases. If 2 documents had the same hash value, then changes made in one file could change the other, or eventually use collisions to decode the encryption algorithm and learn how it works. Preventative measures can be taken. Using a hash function that produces a larger hash output, for instance, moving from 128-bit hash to 256-bit hash, squares the security. This is because The number of possible hashes doubles with each additional bit, making it harder for a collision. Another preventative measure is the use of salting. A salt is random data that is used as an additional input to a hash value. By salting a password, even common passwords end up with unique hashes, thereby reducing the efficiency of pre-computed tables of hashes that an attacker might use in a birthday attack. So I will show you how to create two programs that are not identical, but will have identical MD5 hashes. All right, so let me just sign in really quick. Just check if it's here. So I'm going to be using the Evilize program. It's a program you can download. And we're going to unpack the archive right now. Seems you got a typo. And this is going to create all the different programs we're going to use. Okay, so this created a vector so we can find the MD5 collision. So now we're just going to run the MD5 call program with this vector. Oops, my keyboard fell. Oh, what was it? Okay, so this might take a while. I'm going to pause the video. It took longer than expected, but let's continue. Okay, so we have two files now, and we'll compare the hashes right now. Sorry, at the 5. Okay, so we have the hash for this file right here, and they're the same. But if we run both the programs, you see we've run the good file or good program. It says hello world, and if we run the evil program, it's erasing our hard drive. All right, thanks.